Hello, today we are doing section 6.8. In this question, in this section, you're gonna learn about limits, specific kind of limits, which are called indeterminate forms. Okay, so indeterminate forms are if a fraction is of the form 0 by 0 or infinity by infinity or 0 by infinity. We use L'Hopital's rule. So this is a French name. Some people call L'Hopital's rule. Some people also end up talking about L'Hospital's rule. There's no S in there, so I just pronounce it L'Hopital's rule. Okay, so you can find your own pronunciation. Let's read the rule. If I be an open interval containing a number A, suppose f and g are two differentiable functions. Differentiable function means that you are able to find the derivative of both of these functions, and derivative of g of x is not equal to 0 for all x in that interval, which interval you are talking about, I. Okay. Suppose that one of the following holds, except possibly A. Either both the limits of f of x as x approaches to A and the limit of g of x as x approaches to A as 0. So remember, we are talking about a function f of x by g of x. If we are trying to find the limit x approaches to A, then this limit, if both of these limits are approaching to 0, is 0 by 0 form. Okay. Or if the numerator's limit is either infinity or negative infinity, and also the denominator's limit is infinity or negative infinity, that's infinity by infinity format, but plus minus sign. Okay. Then this is the rule. Conclusion of the rule. It says the limit of f of x by g of x can be same as limit of derivative of the numerator divided by the derivative of the denominator. Pay attention, this is not the quotient rule. Do not use quotient rule here. I'm pointing it out because a lot of times students do that, and this is not really the quotient rule. It's easier than that actually. So don't confuse yourself and do the difficult thing, right? And also the wrong thing. You need to simply derivate the numerator separately and write the derivative of the denominator in the denominator's place, then find the limits. That is what your L'Hopital's rule is. Rule remains valid for one-sided limits also, like if we have only two left limit of A and left right limit of A. Since we are dealing with quotients and derivative, there is a temptation to use quotient rule. Don't do that, right? I told you, do not do that. We can apply the rule multiple times as need, as long as we still have indeterminate forms. Indeterminate forms are when limit is in the 0 by 0 form or infinity by infinity form. We'll do more indeterminate forms later, but right now let's focus on these ones. Let's do an example to explain it. So here is the question, limit of this function. If I put 2 in there, so what will be the numerator? 2 square plus 5 minus 3 divided by 2 square minus 4. The numerator will be 4 plus 5, 9 square root of 3 minus 0 divided by 2 square minus 4 is 0. So this is an example of 0 by 0 form. This is an indeterminate form. Which form is this one? 0 by 0 form. So we can apply L'Hopital's rule to this. Okay, let's actually try the rule. Limit, we need to find this. Now, I do want to remind everyone that in your Cal 1 class, your teacher would have probably shown you this using rationalizing. And that's a perfectly fine way of doing that too. But here we are teaching a simpler way, L'Hopital's rule. So what we are trying to say is if I put this limit, if I differentiate the numerator and differentiate the denominator, then the limit stays the same. So let's show you guys how it's done. So you're gonna write limit same x approaches to 2. In the denominator, you're gonna write the derivative of the denominator. What's the derivative of denominator? Just 2x. In the numerator, you're just gonna write the derivative of the numerator. What's the derivative of this? This is square root. So square root's derivative is 1 by 2 square root of x squared plus 5 times the derivative of inside is 2x. Okay. Minus derivative of 3 is 0. So I don't really need to write it. Okay. So pay attention. I did not do L'Hopital's rule. I just differentiated the numerator and differentiated the denominator and wrote the limit. Whenever you'd use L'Hopital's rule, I have a convention in the book used that you write this equal sign with the H on top. This symbol stands for that you applied L'Hopital's rule. Okay. Let's do the limit further. This 2 cancels with this. That I'm gonna just write one more time. Can be written as 1 by 2x square root of x squared plus 5. If I put 2 in here now, this does not becomes indeterminate and the denominator does not become 0. So that will be 4 square root of 9, 4 times 3. The answer should be 1 by 12. Okay. So that's the basic method of L'Hopital's rule. L'Hopital rules apply. Let's go over one more time. L'Hopital rule applies if when you plug in the limits, it becomes indeterminate form. So you can quickly, you don't even have to show me this work. You can just say, oh, I applied this is 0 by 0 form, and so I can apply L'Hopital's rule. So the limit is equal to the derivative of the numerator divided by the derivative of the denominator, and you still need to take the limit. Okay, simplify it with all the correct algebra and then see if you can find the limit now. If you can, that will give you the answer. Okay.